Here we have lesson 5, special angled pairs. We'll see a bunch of different things in here. I'll be able to identify the relationship between angled pairs such as adjacent, vertical, linear. We'll see some other terms in here described. Let's take a peek. Like this term, perpendicular lines. Two lines that intersect to form 4 right angles. Represented symbolically with this notation, it's kind of a big upside down T that means perpendicular. In this picture, we've got our right angle marked here. They're actually 4 right angles. They're all right angles. And it might be written that line M is perpendicular with the upside down T to N. It means that they intersect at a right angle here. And actually all 4 are right angles. Look at example 1. And line NP and QR are perpendicular lines. So first thing I do when I see that is I mark at least one of the angles. Let me know that it's a right angle. You can mark this one here or whatever. Or this one over here. They're all right angles. 90, 90, 90, 90. So to solve for x, I can see that the measure of this angle equals 90 degrees, or 5x minus 5 equals 90. We'll go ahead and solve that. Get rid of that subtraction with addition. And last, divide by 5 and get x equals 19. Next, we have a bunch of definitions on our notes page. We'll look at this picture and what adjacent angles are. Angles that have a common vertex. So all these angles have the same vertex here, Z, and a side, a common side, but no common interior points. In this picture, I should have numbered them, made it easier to say, but basically adjacent angles are side by side. Let's take a look at a couple pairs here. WZX and XZV. Let's see if I highlight those. WZX, that angle, and XZV, XZV, this angle right here. You can see they're side by side. They share this same vertex. They share this common side, but the interior is different from each of them. They don't overlap. That's basically what it is. Okay. Adjacent angles side by side. Here I wrote the rest of, I just did this different picture here. A lot of times when we have a bunch of angles in a picture, they can number them, so their numbers are their names, not their measure. Here's angle 1, angle 2, angle 3, angle 4. So in this picture, you can see adjacent angles side by side. 1 and 2 would be adjacent to each other, or 2 and 3 would be adjacent to each other. They share this common side here, right, side by side, or 3 and 4. In this picture, there are a bunch of them. You could take this red angle and the one next to it here. These two would be side by side or adjacent. This one and this one would be adjacent, and go around it just picking out a pair of side by side angles sharing a common side. Next, we have non-adjacent angles, which of course don't share a common side. Angles that have a common vertex but do not have a common side or common interior points. So looking at this picture, we could pick out a pair. There's actually 2 pairs of them. WZX. Let's see, WZX here, this angle, and VZX. I'm sorry, VZY. So these two They share the common vertex, but their sides are totally different. They don't share a common side. In that other picture with those other four angles, if I looked at this one back here, then of course you could say 1 and 3 are not adjacent, or 1 and 4 are not adjacent, stuff like that. 2 and 4 aren't adjacent. They don't share a common side. They're kind of separated. They're not side by side. Okay, so that's non-adjacent. Vertical angles in this picture are like non-adjacent angles, you'll see. Two non-adjacent angles formed by two intersecting lines. So we've got to have the two intersecting lines. In that other picture, we didn't have two intersecting lines, really. Okay, we had one line and a bunch of rays sticking out of it. Vertical angles are always congruent. So the non-adjacent, just like we did before, so we've got this one and this one here are non-adjacent, and they are considered vertical angles. We got two lines intersecting like this, and they can't be side by side, so this one and this one. And it says they're congruent. So we put those also. But the other pair of non-adjacent vertical angles in this picture, I'll color in blue here, is this angle right here, VZX, and YZW. They're formed by, again, these same two lines intersecting. These aren't side by side, they're not adjacent here. And they would be congruent. This angle measure would equal this angle measure on this side. So the red ones are equal, vertical, non-adjacent in this picture, and so are the blue ones. They're equal to each other. A linear pair. Linear means line, pair means two. A line cut into two angles here, we'll see. Two adjacent angles, so they got to be side by side, whose non-common sides are opposite rays. Well, you'll see there's an easier description. The sum of the measures of the angles in a linear pair is 180. So basically, we take a line and cut it into two angles. So here's a line. If I cut it with this ray right here, it's cut into this angle right here, XZV, and this one right here, VZY. They're not equal. I'll put a 2 mark here. But they share this common vertex. They're adjacent, right? And they're non-common rays that say form a straight line. But it's basically a line cut into two angles. And of course, you can see that these have to add up to 180 degrees. There's that straight angle. They kind of combine together, make this straight angle 180 degrees right there. That's why a linear pair is also always adds up to 180. Now there's more than one linear pair in this picture. You could look at another straight line in here if I erase this and look at this line. We can see there's a linear pair on this side, this angle and this angle. Make a linear pair, add up to 180. Also on this side of it, this angle and this angle form a linear pair. There's a straight line on either side. So this adds up to 180. This adds up to 180. Same with that other line, had linear pairs on both sides of it. So just a little recap. Vertical angles are congruent, which means their measures are equal. So here we have the two intersecting lines. Later we may see 3 and see how that works. But a linear pair, when the intersecting lines are not adjacent, they're not side by sides, they're across from each other, and they are congruent. If this was 60 degrees, oops, not writing too good, and this one would be 60 degrees. And then the linear pair here, again, remember that they're going to add up to 180. If this was 40 degrees right here, We'd subtract 180 minus 40. That would leave us with 140 degrees right here. We'll be using those a lot, vertical angles in linear pairs. So let's take a look at our first picture. Let's see. Line AC and DE intersect at point B. Find the value of x and the measure of angle EBC. So first, to find the value of x, we have to have an equation. We look at this picture and we see that this 2x plus 20 angle and this angle here that measures 3x plus 15, these are vertical angles, and vertical angles are congruent. So we'll start with that, which is not that one. Come back, little box, I'm sorry. Is this one. Here they are equal to each other. We'll solve this for x. Subtract 2x from both sides. We don't want x's on both sides. So we get 3 minus 2x is 1x plus 15 equals just 20 over here. I'll get rid of that plus 15 and isolate x by subtracting 15. And we get x equals 5. Now, let's see what we got here. I kind of did that prematurely. Let's see. Angle EBC. EBC is this angle right here. E to B to C. So we don't know anything about this angle, except that it's side by side with this one and forms a linear pair, that these two angles have to add up to 180. So now I can say the measure of angle EBC plus this angle, which is 2x plus 20, those will add up to 180 since they're a linear pair. And I also know what x is, so my first step is going to go ahead and solve this substitute the 5 in for x here and get that. You could have done it here and got the whole angle measure, but I'll just do it like this. So now I know the measure of angle EBC plus 2 times 5 plus 20 equals 180. We'll simplify this side here. 2 times 5 is 10 plus 20 is 30. So the measure of angle EBC plus 30 equals 180. So I'll subtract 30 and get that angle we want. The measure of angle EBC equals 150. Not too bad, okay? We started off with our vertical angles are congruent, got our equation to solve for x. Saw that we knew nothing about this angle except that it formed a linear pair with this one, that they got to add up to 180 degrees. So we wrote our equation that way and solved it for that missing angle. Here we have another one, the quick check. You might want to pause the video and try it by yourself first, see if you can get it. Similar problem, we do have the vertical angles here, so we'll start there by setting them equal to each other and solving for x. I'll get rid of these 13 x's over here. Don't want x's on both sides. So now 16 minus 13, we got 3 minus 20. The x's are gone here. We got the 7. We'll isolate the x term, get rid of that minus 20 with plus 20. We end up with 3x equals 27. Last, to undo that multiplication with division, and get x equals 9. So let's see, they want the measure of JIH. Let's see if I highlight it here. From J to I to H. So it's similar to that last problem. We know that these two got to add up to 180. They're a linear pair. So we'll go ahead and put that down like that. I've got the measure of that one we're looking for, plus this one, the 16x minus 20 equals 180. So we'll substitute our x number 9 in there for the x and the 16x. Simplify that there. 16 times 9 minus 20 is 124. You might want to check me on that. Subtract the 124 from both sides and we get the measure of that angle, JIH equals 56. Couple of new terms here. Two angles that have a sum, which mean add up to 180, are called supplementary angles. For instance, if one is 60 and 120, these add up to 180. So we say A and B are supplementary angles. Complementary angles are two angles that have a sum or add up to 180. Of course, I'm sorry, 90. Angle A is 30, B is 60. These add up to 90. These are complementary angles. Something to remember, that here's a picture of a linear pair. Angle 1 and 2 are a linear pair. Remember, they add up to 180, so they are also supplementary angles. Linear pair is supplementary. This picture, we have a right angle here, or that these two, this segment and this segment, are perpendicular to each other. So we cut that angle, that 90-degree angle, into two angles here. 1 and 2 would be considered complementary, because these two would add up to this 90, this right degree angle here. So example 4, what do we have here? I look at the picture. These aren't vertical angles. This is a linear pair. This angle plus this angle has to add up to 180 degrees, so that's our equation to solve for x. We got to be looking for those vertical angles or linear pairs. This is a linear pair, so these two add up to 180. Where is my equation for that in this mess? I'm guessing here's the linear pair in the picture. They are supplementary. They add up to 180, a linear pair does. So here's finally the equation. This angle plus this angle equals 180. We'll combine like terms over here. The 7x plus the 5x is 12x. The 20 plus the 10 is 30. Couple steps to go. We'll subtract that 30 and get the 12x by itself. We'll divide by 12 and check me on that. I got 12.5. Now angle LMO in the picture, yeah, LMO is right here, is 7 times x plus 20. So we'll substitute our 12.5 in for x. So 7 times 12.5 plus 20 is 107.5. The OMN was 5x plus 10. Or I did it this way. I took the 180 and subtracted 107.5 to get the other one. Or you could substitute the 12.5 in there for this expression. You take either pick. I got 72.5. So there they are. They add up to 180 degrees. That's that one. Looking for linear pair or vertical angles. Or read this one. What did we tell us? Angle 1 and 2 are complements. They're complementary angles. Complementary or complements have to add up to 90 degrees. So there's our equation. This one, angle 1 and plus angle 2 equals 90 degrees. So we combine like terms over here. There's our equation. 2x plus 3x is 5x. The 20 plus 15, 35. We'll get rid of that addition and subtraction. Isolate the x term. Then divide by 5. Again, pause if I'm going too fast. And x equals 11. If they ask you what angle 1 and 2 are, you would just substitute the 11 back in for the x's and figure out, do the arithmetic there. Example 6 is a nice fun one. We'll do this one together. What do we got here? Well, they want to find these missing angles, 1, 2, 3, 4, by using vertical angles or looking for those lines that the angles will add up to 180. So the first one I'm going to do is not, I guess I will. I could do angle 1. What do we got here? The vertical angle would be 4 here. We don't know it. They would be equal. But I can see a line right here. I'll highlight it in red. If I look at this line, then I know from here, adding up this angle, plus this angle, plus this angle, that's 180 degrees. That's what we're looking for. So if you take 180 and subtract 110 and 45, you are going to end up with 25 degrees here. Okay. You can double check me, add up all three of those. That should add up to 180. 25 and 45 makes 70, plus 110 is 180. Alright, so I'm going to get rid of some of that stuff now and look at something different. Find those other ones. We're going to look at some vertical angles now. So that's still 25. If I look at these two intersecting lines now, this one and this one, forget about that third line. I can see there's this angle right here is vertical with this one right here. They're not adjacent, these two big gaps here, but these are vertical angles and they're congruent. So angle 2 is 110 degrees. Then to go find angle 3, let's see, we're going to use those same vertical angle things. So let's erase this red line stuff. 3, let's see which lines form 3. This is one of the sides of 3. We'll extend it over. This is the other side of 3. So if you look at these, this one, angle 3 is vertical with this 45 degrees. So angle 3 is equal to 45. Vertical angles are congruent. And then of course you can see that 1 and 4 are also vertical. So 1 and 4 are equal, so 4 would be 25 degrees like we filled in. So using the fact that cutting a line into whether it be 2, a linear pair, or 3 angles, they got to add up to 180. And then looking for the vertical angles by drawing the sides of this angle. I drew here, started on this side of angle 3 and finished the line. This side of angle 3, finished the line all across, then I could see the vertical angles easy. We got, looks like one more example here. You got to read this. You got to know that this upside down T looking thing means perpendicular. These intersect at right angles. CD is perpendicular to AB. So I can see, I'll highlight it here, CD is perpendicular to AB here, line AB. That means there's a right angle here. Okay, we chop it into 2 angles here, 1 and 2. So I know that whatever angle 1 is, which is 6x minus 3, plus angle 2, which is 7x minus 11, will add up to 180 degrees. They are complementary after that. 1 and 2 are complementary angles. They measure an angle up to 90. So we write the equation that way. 7x minus 3 plus 7x minus 11 equals 90. So we'll combine like terms. We have 13x, and the minus 3 and minus 11 make minus 14. So get rid of that 14 with plus 14. Divide by 13, and we get 8. So x equals 8. You could actually substitute that in there if they wanted the measures of these 2 angles and figure them out. That's it for this lesson. Let me know if you need any help with any of the practice.